Hello everyone! Today we're going to talk about something super cool entitled The Power of Logic Unraveling the Mysteries of Mathematics. It's like a superhero of math that helps us figure out if things make sense. You know, like superheroes that have their powers. Well, logic is the power that keeps our math ideas strong and clear. Imagine, you're building a really awesome tower of building blocks. Each block is like a math idea, and logic is what makes sure that blocks fit together perfectly. That's what we're diving into today. Well, discovering how logic helps mathematicians check if their ideas are right, sort of like being math detectives, from simple ideas to more complex ones, like puzzle waiting to be solved. Logic is the secret sauce that makes sure everything adds up. But wait, there's more. Logic isn't just for math class. It's like a cool tool we can use in everyday life. It has helped us understand if what people say makes sense and if we can trust their ideas. So, let's get ready for an adventure into the world of logic and math, where things make sense, ideas fit together, and math becomes even more awesome. Are you ready? Let's dive in. But before that, at the end of this discussion, you guys will be able to first, assess the validity of various propositions. Second, utilize logical concepts on real-world arguments. Now, what is logic? So in mathematics, logic is a branch of study that deals with reasoning and principles of valid reasoning. It provides a framework for understanding and analyzing arguments, as well as establishing the validity of mathematical statements and proofs. So, logic is concerned with the rules and principles that govern the structure and validity of mathematical reasoning. It helps mathematicians formulate and analyze mathematical arguments, ensuring that conclusions drawn from a set of premises are valid. So, logic is fundamental to the development and understanding of mathematical structure, theorems, and proofs.
I'm L.U.R. Joy M, and next is propositional logic. Deals with the study of logical relationships between propositions or statements. It focuses on the truth values of these propositions and how they can be combined using logical operators like and, or, and not. So, in propositional logic, we use symbols to represent propositions such as P, Q, or R. This symbol can take on either a true or false value. By combining these propositions using logical operators, we can create complex logical expressions and analyze their truth values. So, for example, let's say we have two propositions. P represent it's raining and Q represent I have an umbrella. We can use logical operators to create compound propositions like it is raining and I have an umbrella, or it is not raining or I have an umbrella. So, in propositional logic is the foundation of formal logic and has applications in computer science, artificial intelligence, and reasoning. It helps us to reason about the truth values of the statement and make logical deductions. So, and the next one is compound propositions, are formed by combining simpler propositions using logical operators. These logical operators include and, or, and not. Let's explore each of them. So, number one is and. So, the and operator represents the conjunction of two propositions. It is true only when both of the component propositions are true. And the second is or. So, the or operator represents the disjunctions of two propositions. It is true and at least one of the component propositions is true. The third is not. The not operator negates a proposition. It reverses the truth value of the propositions. Binding these logical operators, we can create more complex compound propositions. So for example, P and Q or not are represent the compound proposition. It is both raining and you have an umbrella, or it's not sunny. These compound propositions allow us to express more nuanced relationships between statements and reason about their truth values.
Logical operations, also known as Boolean operations, are fundamental tools for reasoning and problem solving. They allow us to combine simple propositions to form more complex ones and to evaluate the truth value of these complex propositions based on the truth values of the simpler ones. Logical operations. There are three primary types of logical operations. First is conjunction. The conjunction of two propositions denoted by "and" is true only if both propositions are true. For disjunction, the disjunction of two propositions denoted by "or" is true if at least one of the proposition is true. Negation. The negation of a proposition denoted by "not" is the opposite of the proposition. Applications of logical operations. Logical operations are used in various fields including mathematics, computer science, philosophy, and linguistics. Mathematics logical operations are used to define mathematical concepts such as sets, functions, and relations. Computer science logical operations are the foundations of Boolean algebra, which is used in digital circuits, programming languages, and search engines. Philosophy logical operations are used to analyze arguments, construct theories, and evaluate evidence. Logical operations in linguistics are used to study structures of language and the relationship between words and meanings.
Hi, I am just James and let's talk about proposition and truth tables. True values of proposition is the attribute of the proposition as to whether the proposition is true or false. A truth value table or truth table can be used to determine the true value of compound proposition based on the true value of the original simple proposition. And now let's talk about conditional proposition. Conditional proposition, sometimes referred to as if-then statement, is a compound statement that connected by the words if-then or just. The most logicians use the sign horseshoe to mean if-then.
A conditional statement or conditional propositions, sometimes referred to as if or then statement, is a compound statement that is connected by the words of if and then or just then, and most logicians use the sign of horseshoe to mean if or then. For example, if the airship Albatross has a power weapon, then it can destroy objects on the ground. Conditional propositions is a combination of a conditional statement and its converse written in the if and only if one. Two-line statements are congruent if and only if they are of equal length. A biconditional is true if and only if both the conditionals are true.
Tautologies and fallacies. Tautology is a compound proposition that is true for all possible combinations of the truth values of its constituent propositions. It is also called logically true. And contradiction is a compound proposition that is false for all possible combination of all truth values of its constituent propositions. It is also called logically false or absurdity. Contingency is a compound proposition that can be either true or false, depending on the truth values of its constituent propositions. It is neither tautology or contradiction. So here's the example of contradiction and tautology. Argument. An argument is an assertion that a given set of propositions, called hypothesis or premises, derives another proposition called conclusion. Following the law of logic and rule inference, it is valid if and only if the conjunction of the premises implies the conclusion. Rules of interference. There is a need for a technique or list of techniques that somehow bypass the need for constructing any truth tables, especially large ones. These techniques are called rules of inference or laws of logic. The rules of inference are fundamental in the development of a step-by-step proof showing how the conclusion logically follows the hypothesis. Many rules of inference arise in the study of logic.
So that's the end of our logic math journey. We've learned that logic is like a superhero for math, making sure that everything fits together perfectly. It's our math detective tool helping us check if our ideas are right. Just like building a tower of blocks, logic keeps our math ideas strong. We explore different types of logic from simple puzzle to bigger ideas and saw how it all adds up. But guess what? Logic isn't just for math class. It's a cool tool for everyday life. It helps us understand if what people say makes sense, like having a special power to figure things out. So, as we finish up, let's keep using our logic superpower in math and in the real world. Logic makes things clear and helps us solve all kinds of puzzles. Thanks for joining the fun adventure into the world of logic in math.